Yep, so thank you for inviting me, and I'm going to talk about inequality and the connection to the production elasticity. The motivation comes from the decline in the labor share that was documented by Karabarbounis and Neiman. And what we can see on the y-axis is the share of labor in the income of the economy globally. And on the x-axis are the years. We have the black line, which is the share of labor in the corporate sector, and the red line is the share of labor in the whole economy worldwide. And what we can see is that since about 1980, we have a decline from about 65% share of labor down to around 58, 59% in 2013, and similar decline in the overall economy. And two contentions arise from the Karabarbounis and Neiman paper that I will try to settle here. The first contention is regarding the elasticity of substitution. Karabarbounis and Neiman find that the elasticity of substitution between capital and labor is 1.25, significantly above unity, which implies gross substitution, while most other estimates are below unity, implying gross complementarity. So that's the first contention. The second contention arises from Elsby et al. And what they show is that when the elasticity of substitution is above unity, combined with a decrease in the labor share of income, implies capital deepening. And what they say is that capital deepening did not occur, and therefore they discount the findings of Karabarbounis and Neiman. And so the second contention is regarding the capital deepening. In order to address the first contention, we do a time-varying state-space estimation of the elasticity of substitution, thinking that perhaps the different estimates that were taken over time by linear regression and produced fixed estimates did not take into account fluctuations over time in the elasticity. What we want to find is the evolution of the elasticity over time. And so if we start from the marginal productivity of labor equal the wage, and we take logs and rearrange, we get this observation equation that we estimate, where YT is log GDP per labor hour, WT is log wage per labor hour, and sigma T is the elasticity of substitution. So that's our observation equation. We use annual data on output, hours worked, and wages for the period 48 to 2015. And so the results of the Kalman filter for the evolution of the elasticity are in this graph. On the y-axis, we have the elasticity of substitution, where the green line is the threshold of elasticity equals unity. On the x-axis, we have the years, where the yellow line is the threshold for 1980. We are mostly interested in the period after 1980, which is the period in question for the decline in the labor share of income. The blue and red lines are the evolution, the Kalman filter and the Kalman smoother, of the evolution of the elasticity. And what we can see here is as an initial, so we start with a guess, which is the average, 1.05. In this particular case, we see an initial jump to 1.1 and followed by a decline and some fluctuations until it becomes fairly stable between 1.02 and 1.04 between or after 1980. And that period is also fairly stable and not sensitive to initial conditions. So the exact trajectory until about 1970 is fairly sensitive to initial conditions, but after that, it's fairly insensitive. And so we think that that kind of, at least this is only for the US, so I think, for the US at least, for me, it kind of settles the first contention regarding the elasticity of substitution. It can also provides a little bit of explanation why taking an average, doing a linear regression in different periods over the years would have produced different estimates by different people. In order to address the second contention regarding capital deepening, we use a solo model with a continuum of households, L, endowed with 1 unit of labor. The households are endowed with capital such that 10% of the households own 60% of the capital, which, according to the CBO, was approximately the situation back in 1980. All the capital is invested in the firm rather than rented. We have a representative firm with CES technology where Y is output, alpha is the share of capital, T is capital augmenting technology, K is capital, E is labor augmenting education, and L is labor. Education, labor, saving, and depreciation are exogenous. And the firm can change T and alpha, so that's kind of the technical change aspect of the model. So the firm can choose to change T and alpha. And we consider comparative statics, and I'll show why we only consider comparative statics and what are the limitations with capital augmentation. And so the results are that since the firm owns the capital, the profit equals capital income based on the Euler rule. So the firm needs only to pay the labor. And if we take as an example a Cobb-Douglas case, which is the simplest case, with similar results for elasticity larger than 1, then we get a profit that equals the capital income. And what we can see is that there is incentive to increase T and alpha. So if we increase alpha or T, we increase the profit of the firm. And so that is the incentive for kind of a decrease in the labor share. And what we can see here with a steady state capital per effective worker, we can see two things. One is that if we increase T or alpha or both, we will get capital deepening unless the saving rate declines or the other parameters of growth and depreciation increase. So that's kind of the prediction of this model. And the second thing that we can see is that if T and alpha, if we did not consider just comparative statics, if we want to do this dynamically, then what will happen if we have a continuous change in T and alpha, then the steady state is not a steady state anymore. So that's a well-known limitation with capital augmentation regarding balanced growth, and there's a whole separate literature about that. And so, lo and behold, Parker showed that the saving rate did actually decline significantly between 1980. So it declined from around 8% to almost 0 during fairly the same period of the decline in the labor share of income. And so this can provide at least one possible explanation that can settle the contention regarding capital deepening and provides an explanation why we didn't see capital deepening during that period of decline in the labor share when the elasticity of substitution is actually larger than 1. And so in conclusion, what I've shown you is that the production elasticity is larger than 1, which provides an incentive for bias technical change and that lowers the share of labor. The second point is, I'm kind of stating the obvious, is that if you have a wealth inequality like we have in this model, and you combine that with a lower share of income for labor, then you get income inequality. I've shown that the decline in the saving rate provides an explanation for absence of capital deepening. But kind of a warning is that if the saving rate doesn't continue to decrease, and it doesn't have much more room to decrease, then we will see capital deepening. And then we will see both exacerbated income inequality and also exacerbated wealth inequality. And so that's kind of the ending.
The happy ending.
Yeah, exactly. Yeah.